Good morning, students. I hope you all are fine and staying safe. So, let us begin with our class today. So, as we have already studied in the last class about the relative molecular mass, and I have talked to you only superficial way that molecular mass is just calculated by adding up the relative atomic masses of all the various atoms present in a molecule. So today in today's class we'll be discussing that how we are going to calculate the molecular mass of various elements. So first of all, by the help of the example, we'll be learning how to calculate. First we have H2SO4, that is sulfuric acid. So now first we'll be making a table kind of a thing. So first will be element, second number of atoms, atomic mass, and then the total. Now in this compound, if we see that what all elements are there, so we have hydrogen as H, then sulfur, then oxygen, then the second column we have to fill, in which we have to write number of atoms. So now how we are going to calculate the number of atoms of each element. Now hydrogen is here, nothing is written, so that means it is but obvious 1. Here it is written 2. So 2 into 1, that makes 2. Then next element we have is sulfur. So sulfur, here nothing is written, so it means there is 1. And 1 into 1, that makes 1 atom. Now we will talk about oxygen. Here it is written 4. 4 will be multiplied by here 1. So 4 into 1 makes 4. Now the atomic masses will be written. Atomic mass of hydrogen, this will be given in the question. So hydrogen atomic mass is 1. Sulfur, it is fixed. As we have already studied in the last class, these all are fixed quantities, fixed units are there, and it is not changing or varying. Right? So you have to learn few of them as you will be doing the solving various numericals. So you will be by the end of class 9, I am sure you will be learning them all by heart. Now hydrogen atomic mass is 1, sulfur it is 32, oxygen is 16. So just we have to copy it down. Now total is number of atoms multiplied by the atomic mass comes out to be 2. Again, number of atoms multiplied by atomic mass gives 32. Again, number of atoms multiplied by atomic mass, that gives us 64. And then we have to simply add it up all. And that comes out to be the relative molecular mass of that particular compound or molecule. And what we have to not forget is the unit. The unit is AMU, as we have studied in the last class also. So AMU has to be written, and it is compulsory because without unit any answer of the numerical will be considered wrong. So marks will be deducted for not writing the unit. So unit is very, very important. Then we'll discuss the another example. One more example I'll be showing. Here it is copper sulfate pentahydrate. So that is CuSO4.5H2O. So first of all, we have to fill up the first table, that is element. First column, that is element. The elements are copper, sulfur, oxygen, and hydrogen. Right? Remember that we have to write the element and not the compound or the radical. We have to make sure that we are writing all the elements. Now in second column, simply write the number of atoms. Copper has 1 here, nothing is written, so it means 1, and 1 is here. 1 into 1 makes 1. Sulfur again, nothing is written, so 1 into 1 is 1 again. Then oxygen here. Now oxygen is coming here as well as here. So what we are going to write is total. Oxygen here 4 into 1, that is 4. Here again 1 into 5, that is 5. So 4 plus 5 makes 9. This dot simply means that it is water of crystallization, which you have already studied in class 8. It doesn't mean that, like in maths you have done that dot means, in BODMAS you have done that this dot means multiplication. No, it is not. This is wrong. This is absolutely wrong. Dot doesn't mean here as multiplication, but it means a plus sign. It means addition. So these molecules, these number of atoms, we will be adding them and not multiplying. Now hydrogen is here 2 is written and here 5. So 2 into 5, that makes 10. Now simply write the atomic masses respectively. Make sure only one mistake can be done in this case, that you write it somewhere up and down. So that has not to be done. So now atomic masses are written of each and every element, and then simply multiplication. 1 into 63.5, 1 into 32, 9 into 16, then 10 into 1, and then adding them up. So that is relative molecular mass, and the unit is written. Now one more example where the brackets will be used up. So that we will be discussing. The next example is NH4 whole twice SO4. Now first we will be writing all the elements, that is nitrogen, hydrogen, sulfur, oxygen. Now the number of atoms. How we are going to calculate? This is very important, because if this column is wrong, everything else will be all wrong. So this has to be absolutely perfect, because this nothing you have to do, you just have to copy it down. In this you have to do the calculations. So you need to know how to calculate this column particularly. So now nitrogen, here nothing is written, but out this bracket means that 2 number is multiplied by this number also. So this is 2 into 1 into 1, that makes 2, right? Hydrogen means 4, here 4 is written, again it is inside the bracket, and outside the bracket 2 is written, so we will be multiplying it. 4 into 2, that makes 8, and nothing is written here, so that means 1, so simply 8. Then sulfur, easy, nothing is written, it means 1. 1 into 1, because here this whole is a compound, so here nothing is written, so it means 1. So everything will be multiplying. If suppose it is written 2, then we would have 1 into multiplied 1 into 2, but nothing is written, it means 1. So 1 into 1, that makes 1. Here oxygen, number of oxygen atoms is 4 into 1, that is 4. Then simply writing the respective atomic masses, then we will be multiplying. 2 into 14, 8 into 1, 1 into 32, 4 into 16. Simply writing them, multiplication you can do very well, and then simply adding them up, writing the unit as well. So now next thing is percentage composition. Percentage, everybody knows how to calculate the percentage. You have practiced, you have learned in maths as well. So same thing, same concept will be used up. First we'll go with the definition, that percentage composition of an element in a compound. If we have to find out the percentage composition, that how much percentage, that means how much quantity in terms of percentage we'll be calculating in that particular compound. So that we have to understand, and we will be calculating through the formula. So percentage composition, actually what it is simply the percentage by weight of each element present in it. In any compound, how much weight of that particular element whom we have to find out the percentage composition, that is percent by weight of that particular element will be the percentage composition. Now percentage of any element in a compound we have to calculate by this simple formula of percentage. that is total weight of the element in one molecule, that what is the total weight of the particular element, whichever element we have to find the percentage composition, that particular element's weight, we'll be writing it here, divided by gram molecular weight of the compound. That is, we have already how we have calculated, this is the molecular weight multiplied by 100 as it is percentage, and answer will be in the percentage, no other unit, because it is percentage. So simply whatever the quantity and the percentage. How to calculate, how to do the numerical, we'll understand by simple one example. Na2CO3. First of all, the calculating the, because here what we require two things. For percentage composition, we require total weight of the element and the gram molecular weight. So this thing we have to do in this percentage composition also. So our first step will be same as we are calculating the percentage as we were calculating the relative molecular mass, or we can say gram molecular weight. Now writing all the elements, then the number of elements 2, 1, 3, and simply multiplying 2 into atomic mass, 1 into 12, 3 into 16, adding them up. Total weight comes out to be 106 AMU. Now percentage composition of sodium. So what is the amount of sodium? 46. So that we have written, divided by total 106 into 100, and simple calculation. Percentage of carbon, what was the weight? 12, that we have written, divide by total 106 into 100, that is 11.3%. Again, of oxygen, 48 is the molecular mass of that, atomic mass, divide by atomic weight, gram atomic weight, molecular weight, that is 106 into 100, and it comes out to be 45.3. And while writing, please do not give the answer in round off. If it is 43.4, you have to write 43.4. No need to write down 43%. It will not be considered, right? So you have to give exact answer in decimal. Okay, one place or two decimal place as the answers are coming. Now, on the next and the last topic in this chapter, we have the empirical formula of a compound. Now, if we are talking about empirical formula, it is the simplest formula which gives the simplest ratio in whole numbers of atoms of different elements present in one molecule of the compound. So what will be the empirical formula? It simply means that this is the simplest formula. So one more thing is that empirical formula of two compounds can be same, exactly same, but molecular formula will be different. So do not misinterpret that empirical formula and molecular formula are same. They are totally different. So sometimes it happens that empirical formula and molecular formula are same, but there are cases in which empirical formula as well as molecular formula both are different. So again, coming back to the topic, empirical formula is just the ratio we are giving of the atoms which are present in the particular one molecule of compound. Right, so here we have, by the example we'll be trying to understand it, what exactly empirical formula is. H2O2. Now, first we will be writing the number of atoms of each element. That is, H is having 2 is to 2. So common high HCF of 2 and 2 is 2. So dividing by 2 by the HCF of these two numbers, that is 2 divided by 2, 2 divided by 2, that comes out to be 1:1. So that is what H1O1 or simply HO. So this is the empirical formula, whereas H2O2 is the molecular formula. So here in this case we can simply see that both are different from each other. Right? Then one more example. C6H12O6. So what are the various numbers in the ratio of 6:12:6? Their HCF comes out to be 6. So we'll simply divide all the numbers by the HCF, that is 6. So 6 by 6, 12 by 6, 6 by 6. So it comes out to be 1:2:1. That is, what was 1 for? This was C. So C, what is the number? 1. Now second was 12 by 6, H. So H, 2. Again last 6 by 6 was for oxygen. So therefore O. So our empirical formula comes out to be CH2 and molecular formula C6H12O6. So as we have calculated the molecular mass, same way we can calculate the empirical formula mass also. Same procedure, same method. So the empirical formula mass is the sum of atomic masses of various elements present in the empirical formula. This is important. If we are talking about empirical formula mass, so definitely we are talking about the atomic masses of various elements which are present in the empirical formula and not the molecular formula. So whenever we have to calculate some numerical comes in which we have to calculate the empirical formula mass, first we have to make the empirical formula for that particular compound and then we'll be calculating the molecular mass of that particular formula, of that particular compound. So empirical formula mass of H2O2. First it is not H2O2, it is simply empirical formula is what? Empirical formula is HO, right? This we have already done. How we have done? Now H, the atomic mass is 1, oxygen is 16. So 1 plus 16 comes out to be 17 AMU. So this is what the empirical formula mass. This EFM is simply the abbreviation which I have used. This is simply empirical formula mass. So this is how we are calculating. So now you'll be getting a PDF regarding chapter 1, what all exercises you have already got, but again we'll be sending you or posting it on the eCare site where you can see it will be uploaded there. So you can just go through it, that what all questions are there which has to be done by you, and if any query is there you can simply you have the WhatsApp groups or through eCare, whichever medium you want you can use, and those problems will be arising only if you are attempting those questions. So I hope that you all will be doing those questions, attempting them and solving them, and if you have any query you can surely get back to us. Thank you so much, and have a good day and be safe.